This presentation is part of a lecture series on the C++ programming language by Michael Adams at the University of Victoria in Victoria, Canada. For those of you who might be interested, a copy of the slides for this lecture series can be downloaded from the website whose URL is given on this slide. In this section, I'm going to be discussing the software build tool known as CMake. CMake is a very popular open source cross-platform family of tools designed to build, test, and package software. It was created by a company called Kitware. CMake has excellent cross-platform support and can be used with many operating systems and compiler toolchains. CMake is designed to be used in conjunction with the native build environment, that is, the build tools provided by whatever operating system and compiler toolchain are being employed. With CMake, the software build process is controlled by platform and compiler independent configuration files. From these configuration files, CMake can then be used to generate the files needed by the native build environment to build software. CMake can generate native build files for many build environments, including make files for Unix Make, project files for Microsoft Visual Studio, and project files for Apple Xcode. CMake automatically generates dependency information for source files, so there's no need to manually maintain dependency information when using CMake. CMake also supports parallel builds. Lastly, the URL for the official CMake website is given at the bottom of this slide, right here. CMake has a very large user base and is employed in many open source and commercial projects. Some users of CMake are listed on this slide, and they include things like the Clang compiler, the K desktop environment, Netflix, and some very other well-known projects. At this point, I would like to introduce the general process involved in building software with CMake. Before I can do this, however, I first need to introduce some basic terminology. As a matter of terminology, CMake build files are files used by CMake to describe the build process for a software project. The files are created by whoever is using CMake, and the main build file for CMake is called cmakelist.txt. This file, however, may in turn reference other files. The native build tool is a program used to build code for the particular software development environment being employed. For example, this tool is often the Make utility for Unix systems, MS Build for Microsoft Visual Studio, and Xcode Build for Apple Xcode. The native build files are files used by the native build tool to control the build process. For example, the native build files would be Make files for the Make utility, project and solution files for Microsoft Visual Studio, and project files for Apple Xcode. With the preceding terminology in place, we can now consider the build process in more detail. With CMake, the build process consists of two steps. First, CMake is used to generate native build files from the CMake build files. Then, the native build tool is employed to build code using the native build files generated by CMake in the previous step. So strictly speaking, CMake does not itself build code, but rather produces build files that can be employed by the native build tool to build code. The build process is illustrated in pictorial form by the diagram at the top of this slide. To begin, we have the CMake build files, which are created by whoever is using CMake. These CMake build files are then fed into CMake as input, which then produces native build files as output. The native build files are then fed into the native build tool as input to produce build code as output. Before considering CMake in greater depth, I must first introduce some additional concepts and terminology. In order to build software, CMake must know where the software to be built is located and where the outputs of the build process should be placed. In this regard, two key concepts are those of the source and binary directories. The source directory is the top-level directory of the directory tree containing the software to be built. This directory is specified by the user of CMake. The source directory must contain a CMake build file called cmakelist.txt. The binary directory is the directory under which all files generated by the build process are placed. This directory is also specified by the user of CMake. The next key concept to be introduced is that of the CMake cache. As we will see later, CMake allows variables to be used to store values employed in CMake build files. In order to allow for the values of variables to persist across multiple invocations of CMake, CMake provides what is known as the cache. This cache stores the value of variables that are to be remembered across multiple invocations of CMake. Often the values of key configuration variables are placed in the cache so that these values only need to be specified once instead of every time CMake is invoked. Another key concept is that of a build system generator. In order to support many native build tools, CMake provides what are called build system generators. A build system generator, or simply a generator, is an entity within CMake that produces build files for a particular native build tool. For example, CMake provides generators for make files for the Make utility, project files for Microsoft Visual Studio, and project files for Apple Xcode. The generator to be used is specified by the user and is chosen in order to produce the correct type of build files for the native build tool being employed. Another key concept is that of the build configuration. Often it is desirable to be able to handle a number of basic variants of the build process. For example, we might want to be able to build debug and release versions of some software. CMake provides what are called build configurations for this purpose. A build configuration is essentially a variant of the build process that employs a particular set of parameters, such as what would be used to generate a debug or release version of some software. Some generators allow for the building of multiple configurations using a single invocation of the build process. Whether a generator offers such support typically depends on whether the underlying native build tool can build multiple configurations with only a single invocation of the tool. For example, the native build tool for Microsoft Visual Studio can build multiple configurations, such as debug and release versions, with a single invocation, while the Make utility does not offer such functionality. For generators that can only handle the building of a single configuration at a time, the particular configuration to be built must be specified to the generator. Earlier, we were introduced to the notions of the source and binary directories used by CMake. Recall that the source directory is simply the top-level directory of the directory tree containing the source code for the software to be built, while the binary directory is the directory under which all files generated by the build process will be placed. CMake allows considerable flexibility in the choice of the binary directory. When the binary directory is chosen inside the source tree, for example, the same as the source directory, this results in what is called an in-source build. On the other hand, when the binary directory is chosen to be outside the source tree, this results in what is called an out-of-source build. When an out-of-source build is used, the contents of the source tree are not modified in any way by the build process, since the build process is only allowed to generate output in or under the binary directory. In contrast, when an in-source build is used, the build process can generate many new files under the source directory. Out-of-source builds have many advantages over their in-source counterparts. First, out-of-source builds avoid cluttering the source tree with many files generated by the build process. This clutter can sometimes interact poorly with version control systems, for example. Second, out-of-source builds facilitate the easy removal of all files generated by the build process without any risk of accidentally removing source files. To remove all of the files generated by the build process, and only these files, we simply recursively remove the binary directory and its contents. Third, out-of-source builds allow multiple versions of the code to be built from a single copy of the source tree. For example, we might want to build debug and release versions of our code using the same source tree. Due to the many advantages of out-of-source builds over their in-source counterparts, out-of-source builds should always be preferred. In fact, the use of in-source builds are generally considered a bad practice that should be avoided. Recall from earlier that the build process with CMake consists of two steps. First, the CMake software is used to generate the build files needed for the native build tool. Then these build files are given to the native build tool in order to build the software. At this point, we will now consider how to perform the first of these two steps, that is, how to generate the build files for the native build tool. With the CMake software, the program used for performing the build process is called CMake, in all lowercase letters. To generate build files for the native build tool, we invoke the CMake program using a command line of the form shown at the top of this slide, in other words, what's shown here. The CMake program takes as parameter 0 or more options, followed by an optional specification of the source directory. The binary directory is always implicitly assumed to be the current directory. If the source directory is not provided as a command line parameter, this directory defaults to the current working directory, resulting in an in-source build. Some of the options supported by the CMake command are given at the bottom of this slide. So the first option listed is the -D option. This is used to set the value of a CMake variable. In particular, it sets the variable denoted by VAR to the value denoted by VAL. The minus capital G option is used to specify the build system generator to be used. In other words, this determines the type of build files that are generated by CMake. For example, make files for the Make utility or project files for Microsoft Visual Studio and so on. The version option is used to tell CMake simply to print the version number and exit without actually doing anything. The help option tells CMake to print some help information and exit without actually doing anything. And the debug output and trace options are useful for debugging CMake, in other words, debugging build operations when things aren't quite working the way you would like them to. The CMake program supports a number of generators. Which specific generators are available will depend on the particular platform on which CMake is being used. The few commonly used generators include the ones listed on the slide. For example, there's a generator for make files for the Make utility, for project files for Apple Xcode, and for project files for Microsoft Visual Studio 12. The makefile generator produces a top-level makefile with the standard targets, for example, all, clean, and install, as well as targets corresponding to each CMake target in the project. CMake also allows some configuration settings to be established using environment variables. For example, the specific commands to be used to compile C++ and C source code can be set via the CXX and CC variables respectively. As far as the documented functionality of the CMake command is concerned, the binary directory cannot be specified on the command line and is always implicitly assumed to be the current working directory. Unfortunately, this behavior is sometimes inconvenient. Therefore, in passing, it is worth noting that an undocumented feature of the CMake command exists which allows both the source and binary directories to be explicitly specified by the user. In particular, the -H and -B options can be used to explicitly specify the source and binary directories respectively. If these options are used, however, there cannot be a space separating an option letter and its corresponding argument. For example, the source directory must be immediately following the -H option without any intervening space, and similarly for the -B option. Again, recall from earlier that the build process with CMake consists of two steps. First, CMake is used to generate the build files needed for the native build tool. Then, the native build tool is invoked to build the software using the build files generated by CMake. At this point, we will now consider how to perform the second of these two steps. That is, we will consider how to invoke the native build tool, passing it the build files generated by CMake. As it turns out, we have two choices for how to invoke the native build tool. We can either invoke it directly or invoke it indirectly using the CMake command. The advantage of the first approach is that it may potentially offer greater control over the native build tool. The advantage of the second approach is that it allows the native build tool to be invoked in a manner that is independent of the particular native build tool being employed, and therefore requires no specific knowledge of the underlying build tool. This advantage can potentially be quite significant when doing cross-platform development. For the sake of independence from the platform and compiler toolchain, it is probably always advisable to use the CMake command to invoke the native build tool, unless a compelling reason exists to do otherwise. Since I do not wish to bias this presentation towards any particular native build tool, I'm only going to consider the approach of indirectly invoking the native build tool via the CMake program. To invoke the native build tool indirectly via the CMake program, we can use a command of the form shown at the top of this slide. The --build option indicates to the CMake program that we wish for it to invoke the native build tool to build software as opposed to generating build files for the native build tool. The binary directory needs to be specified so that the CMake program can find the build files that are to be passed to the native build tool. When the CMake program is invoked with the --build option, a number of other options can also be used. Some of these options are listed at the bottom of this slide. So for example, we can specify explicitly what target that we want to build instead of whatever the default is. So we can use the target option and then specify a target that we want to build. We can specify which particular configuration that we want to build if we have a multi-configuration generator that's capable of building more than one configuration. We can specify the clean first option to cause all the files that are generated by the build process to be removed first before building to make sure everything is clean when we first start the build process. And then we can specify the double minus sign option to say all the remaining options are to be treated as options to the native build tool as opposed to options to the CMake program itself. At this point, I would like to consider a simple example of using CMake to build some software. The software to be built in this example is the classic Hello World program written in C++. For the purposes of this example, let $sourcedir denote the directory containing the source files for the software. The directory $sourcedir contains two files, cmakelist.txt, the main build configuration file for CMake, and hello.cpp, the single C++ source code file for the Hello World program. The contents of each of these two files are shown on the bottom half of the slide. From the contents of the file hello.cpp, we can see that the Hello World program simply prints a greeting message and exits. Now let us examine the contents of the CMake list file. In a CMake list file, a hash character begins a comment that continues until end of line. So lines 1, 4, and 7 contain comments. The first command in the CMake list file appears on line 2, with the command being called CMake_minimum_required. This command specifies the oldest version of CMake that is permitted to be used to build the software. Since newer versions of CMake sometimes add new features, it is often necessary to restrict the version of CMake that can be used to process a CMake list file in order to ensure that all of the CMake features required are available. In this particular example, the version of CMake is being restricted to version 3.1 or greater. The second command in the file appears on line 5, which is the project command. The project command specifies the languages that are to be used by the software to be built. In this case, the name CXX is used to specify the C++ language. The last command in the file appears on line 8. In particular, this line contains the add_executable command. The add_executable command is used to define a target that corresponds to an executable program. A target is simply an entity that CMake can build. The arguments for the add_executable command specify the name of the target and the source code files associated with it. In this particular example, we have an executable program target called hello, which is to be built from a single source code file called hello.cpp. Suppose now that we wish to build the software in this example using CMake and place the files generated by the build process in a directory that we denote by $binarydir. To accomplish this, we can use the sequence of commands shown near the top of the slide, namely these commands here. First, we set the current working directory to $binarydir and then invoke CMake to generate the build files needed for the native build tool. Then we invoke the native build tool indirectly using the CMake command with the binary directory specified as the current working directory. Now I'm going to give a short demonstration of CMake for the Hello World example. My current working directory is set to the source directory for the software. So if I list the contents of the directory, you'll see there are two files, the ones that we saw earlier on the computer slide, cmakelist.txt and hello.cpp. And I can output the contents of these files to the screen. So cmakelist.txt looks like this, and hello.cpp looks like this. At this point, I need to create the directory that I'm going to use as my binary directory, the place where the output generated by the build process will be placed. So I'll create a new directory called tmp, and then I'm going to set my working directory to this new directory. And of course, if I list the contents of this directory, there's nothing there, it's empty, I just created it. Now I'm going to run CMake to generate the build files for the native build tool. And when I run CMake, I have to give it the directory, which is the source directory, which is my parent directory, or ... And then when I run CMake, it prints out some messages about what it's done, and it's told me the build files have been written to a particular directory, which is the binary directory that I'm using. Now if I list the contents of the directory that I'm using as my build directory, you'll see that there's a bunch of files that have been created. In particular, there's a make file that's been created, because in this particular case, I'm using a system on which the default generator is Unix make files, basically a Unix-based system. So it's created a make file, and the underlying build tool that I'm going to be using is make. At this point, I actually want to build the software, so I'll use CMake again, but this time I'm going to invoke it in order to use the build files that have been generated and actually run the build tool, which is make in this case. And I specify the build directory, which is the current directory ... And it prints out some messages about what it's done. It's built the target hello. And if I list the contents of this directory now, you'll notice that there's a file called hello, which is the program that was produced by the build process. And I can run this program if I like, It just prints the message hello world. At this point, I would like to consider the hello world example again. This time, however, I'm going to invoke CMake in a slightly different manner from before. In particular, I'm going to use the -H and -B options of the CMake program in order to explicitly specify both the source and binary directories. Again, my current working directory is set to the source directory for the software. So if I list the contents of the directory, we'll see there's a CMake list.txt file and hello.cpp file, which have the same contents that we saw earlier. At this point, I'm going to run the CMake command to generate the native build files, and I'm going to specify the binary directory as a directory called tmp, which doesn't exist and will be created by CMake. So in particular, I'm going to use the command shown here. So the -H option sets the source directory, so I'm setting the source directory to dot, which is just a nickname for the current directory, and the -B option sets the binary directory, which I'm going to specify as temp. Since this directory doesn't exist, it will be created by CMake when I run this command. So if I run this, it prints out some messages about what it's done. It indicates build files have been written to the binary directory that I specified. And if I list this directory, you'll see that it now has a bunch of files in it. In particular, it has a make file. On the particular system that I'm using for this demo, the default generator is for make files. So it will produce make files by default and assumes you're going to use the native build tool make. Now if I run CMake a second time, this time I'm going to actually build the software using the native build tool, which in this case is make. I specify the build directory as temp, the directory that I just created, and then I just run CMake, and it builds the software. If I then list the contents of the temp directory, you'll notice that there's a file called hello. This is the executable program that was just generated by the build process. And then of course I can run this particular command, and it just prints hello world.